Hello everyone, in this video I'm going to walk through a couple of different forecasting techniques so that you can observe the differences between them. Sometimes the naive method is all you need in a business, but it does differ between data set and time periods and things like that, so you do want to be careful. But oftentimes we see the naive method as the easiest way, and then multi-regression as the most difficult, more data-intensive way to do a forecast. So I want to walk through each of these here with the same data for us. Okay, so we've got some fondue. Delicious stuff. I had it over the weekend. Wonderful. We've got some basic calculations here: the mean, the sum, the standard deviation, and coefficient of variation, one of my favorite formulas. I have them across all the data sets. They're all the same. Only difference is apparently I bumped this up to 250. So we'll fix that here so that you can see it to the best possible recording quality. So I'm going to canvas the data. I've got product name. I've got time period index, which is just basically 1 through 9. I don't know what month this is or week or anything like that. Actual sold of this dish. And then day of the week that corresponds to that sale. And then the average temperature for that day. And then I've got a forecast here of nothing that we're going to fill this in. So the first thing I want to do here is I'm going to go ahead and show you the calculations here. So we'll do the average. And then we'll do the sum of total ordered. We don't need this for the forecast, but it's just good to know kind of things as far as the sum there. But the standard deviation, you have several choices here. I like to go with the plain vanilla original one, and we'll just grab that information. And so basically it means we have an average of 26.3, but generally speaking, we can see the distribution going to 29.5 or 23.1, somewhere around there where most of the values would fall. And in fact, if you look at the data set, it's pretty much where it is. Now, obviously, we have one here that's below that threshold of 26.3 minus 3.2 for that standard deviation, but it's pretty darn close. But generally speaking, we also have one here, 33, so we have a big day. Interestingly, that's the Saturday. So you might start thinking about seasonality in your data set. For example, does the weekday perform better than the weekend? What's that have to do with anything? You might run a model to look at that. And coefficient of variation here. Now, the thing that I like to do is and here's the quick tip for everybody. You don't have to retype all that. If I want to take the average of temperature and standard deviation, any of that stuff, I can actually grab the data, copy it, and paste it right over. And now I've got all of this pointing over here. Now, you might ask yourself, what's the point with these statistics? Well, not much. In fact, you don't sum up a temperature. Doesn't make any sense. So we can get rid of that one. But look here, we have a coefficient of variation, which is standard deviation divided by mean. So this divided by this of 12%. But over here, the temperature varies much more greatly. The temperature is lower than the sold, so don't count those. But what you can count, kind of take an eye of is these here against these, and you see there's much more variation, almost essentially twice the amount of variation, deviation there from the mean. So the temperature is a little bit more wilder. So I'm starting to get a hypothesis here that temperature doesn't have a lot to do with the data set, especially because this is much more violent or variable, whereas this is calmer. Still 12% is 12%, but it's calmer for this, almost 3 times, greater. So yeah, so that's what we want to think about as we start going here. Okay, so now that we kind of studied the data, again, I want to show you something here. Let's copy this and note that we're in C12. If we go all the way over here to C12, well, make sure you don't make a mistake with your keyboard. And we got all the data there, all the data there. Now, again, the data should stay the same because the numbers are the same, but I just showed you a way to copy and paste formulas so you don't have to retype all this stuff across each sheet. So a nice little trick there. Okay, so the naive method is basically NA, because you can't calculate anything beforehand. So if you remember correctly, it's the previous actual. So we're just dragging this thing down here. And now we can go over here to forecast error, which is actual minus forecast, or over here minus the forecast, and drag down. And now we have our numbers. We can't calculate that one. We can take this, take it over here, and take it over here. Now we do want to have that sum for forecast and sum for forecast error. We just don't need it over here for this one. I'm just going to denote that here with cross out color. Basically, our forecast error when we balance everything out is only 4, which you might say to yourself, darn, that's pretty darn good. Yeah, except for the fact that we were way high over here. We were pretty low over here. So we do have forecast error in here. That's why businesses will often do spread forecast error or absolute. So let's go ahead and do absolute forecast error. So this is where we take the ABS value. Again, we have NA, and we'll have NA there. So we take ABS as absolute. In other words, it chops off the negative, put simply. And we'll drag this down. And now we can copy all this over as well. And you can see here how we've got quite a different number. It's gonna fix these calculations here. Not that it's gonna matter, but just look at how crazy the coefficient of variation is over here. But when we put it all in one direction, it does a couple things for us. It shows us 26 units of error instead of the 4. This is what I call the camouflage effect. When you sum something and there's negatives and positives, it doesn't look as bad, but in reality, we were off by 26 units. Now imagine we had to buy extra cheese, extra bread, extra meat because of our forecast. We really would have been losing a lot of money. We would have underprepared, so we would have sold out of our meals perhaps and upset some customers. I don't know about you, but I love cheese. I love fondue. I love cheese curds. And if a restaurant doesn't have them, I might not come back. If they ran out, it'd make me question their quality, their level of service, their commitment to the customer if they're running out all the time. So it can be very important. But at the same time, a business might need to forecast something, especially a restaurant, in order to buy as little as possible to keep it as fresh as possible, knowing that there's a shelf life on a lot of foods. So you can see here how absolute forecast error can really help us knock out this camouflage effect that I talk about. So we're going to move on here and see what we can do better with a simple regression equation. Okay, when we look at simple regression, we've got a couple of options here. We could do the day, and I'll teach you how to do that in the multi-regression tab because you cannot calculate or use text. So I'll show you how to do that later. But we'll go ahead with the temperature here, and we're going to use that in our forecast. So we're going to do a simple regression, which is just using one independent variable and the dependent variable. So what we're going to do is we're going to go up to this data analysis pack over here, and we're going to go down to regression. And we're going to, our Y range is what we want to predict for. So in this case, we want to predict the sold, so we know how many we can expect to sell. Now I chose to put the header in here, and it's very important that we click on labels next. Now I'm going to grab temperature because my hypothesis is that there's a relationship between quantity sold and temperature that day. For example, fondue is a hot food, so maybe more people come in from the cold, the bitter cold of Minnesota, and buy some fondue to keep warm. Now you have to check mark the labels here because I did collect them, and I'll explain it in a minute. It's very important. We're going to click the output range here. It's very important too when you click the output range that you go back to this white box because Microsoft Excel is going to want to click up here. So we're going to go to G there. Actually, no, we're going to go over to H, and we're going to hit OK. So now we have our values. So we have an R-squared of 0.03, which right away suggests this model is going to be horrible. Now I'm going to zoom out here a little bit. So this is the stuff that I care about, that I want you to study up on and review and understand a little bit as a barometer to know if you've got a good model or not. We're not going to sit here and calculate all this out, but I just want you to be aware of trouble spots in your model to investigate or change something up. So first of all, we want an R-squared of 0.7 or higher, and this one clearly is not good at all because it's almost 0. So right now, off the bat, we know that we got some problems with the model. F statistic is 0.62. We want that under 5%, so 0.05. But right off the bat, we know we have 2 strikes against this model. And then p-value, which is more about your sample size and the sporadic nature of your sample size. We've got a 0.62 here for temperature. So this model is basically saying temperature is not going to be a reliable variable for this model. And then the coefficients, these are usually fine, but these are the things that we multiply against. So if you're familiar with y equals mx plus b, this is what we're going to use here to make our forecast. So let's go ahead and use those values here. So what I'm going to do is equals this, so temperature times the actual temperature, okay, plus this, and then we're done, because that's the intercept. So now we have our forecast here. I'm just going to bump this so that we have just whole numbers here. It won't be perfect, but and then I don't want you to drag down because then we cause problems. We want to absolute cell reference this stuff. So we want to absolute cell reference everything in I. Okay. So we'll put those dollar signs in there. It'll be very tricky on the I's if you're not careful. And then we'll drag down. There's our forecast right there. I'll button this up a little bit. And we can do the same numbers over here. Copy these, paste them over here. Again, just like we did for the naive method when we did our forecast right here. So we'll do forecast error. And we'll do absolute forecast error. Okay, so one thing I want you to look at here. Do we have forecast error in G and absolute in H for the other sheet, G and H? Yes. So here's what you can do. You can actually copy all of these formulas. Now we'll have an NA and we'll fix that in a minute. So paste all these down, and I'll drag this up, and drag this one up, and now we've got all this. We just want to make sure that our functions are all calculating the same things. Like right there, we're not. So we want to fix that. Not that big of a deal, easy to fix. Okay. Okay, so we have our numbers here. They look pretty chaotic. And I'll explain those in a minute. I'm just going to bump these. And maybe saying, wow, what is that number? Why is it so crazy? It's because we're taking this divided by essentially 0. So if you look at it, we don't have any forecast error here when we add all this up. That's what regression does, by the way. If you go back and look at regression and least squares method, it's trying to pin the line, regression line, to where there's the least amount of error on the upside and the downside of that line. So we would expect this to be 0. And whenever you divide something by 0, you get a really crazy chaotic number. So that's what's going on here. I'm not too worried about this one, but it is annoying, so I'm going to get rid of it. And here, if you ever see an E, it basically means 0. It's so close to 0. It's not that you did anything wrong with that E there. But we'll bump this to, I just hate decimals that far. So here's the absolute forecast error is 20. So we look back, the naive method produced absolute forecast error of 26. We have 20 there, so clearly simple regression is better than the naive method. But I would argue this model is junk. So you want to be careful here. Don't assume that this model is good only because it beat the naive method, okay? It's still junk. It's just that the naive method was really bad. It was worse than this one. That's all it's saying. So let's go into multi-regression and see if we can learn anything from that. Okay, there's a couple ways we could do this. I need to get this into a numerical format. So a couple ways. We could encode this to say Monday equals 1, Tuesday equals 2, Wednesday equals 3, Thursday equals 4, etc. We could come in here and type it in like 1, 2, 3, 4, 5, 6, 7, 1, 2. Or we could say, hey, I want to study whether the weekend or weekdays produce better results. So on one hand, you could do it based on the day of the week, which is totally fine. Or we could do a weekend variable here. Weekend. So what we could do here is an if statement that says if or. If this equals Monday, or it equals Tuesday, or it equals Thursday, etc., put a 1 else a 0. Or we could create a table where we put a v, where we use a VLOOKUP to bring back a value. So let's go ahead and do both ways. So the first way I want to show you is building a little, I call it an index. So we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now this Happy Day song's coming out of my head. And we can put in, is this a weekend? And a 0 means no, it's not. So include Friday and there. So now you got our 1s and 0s, Friday, Saturday, Sunday. And we can do a VLOOKUP now against Monday and bring over the second column here, which will be a 1 or a 0. And there's our 3, and then there's our 0s. So that's one way that we could do this, and it'll work just fine. But there's another way we can do this. It's a little more complicated and prone to error if you're not careful. In fact, when I do this, I might make the error myself. So it's called the if-or function. If or, if this equals Monday, and then you just keep going with this. So we're going to cheat and copy and paste this in there. So that's Tuesday. I'm going to show you a few, and then I won't bore you by doing them all. But we're just basically going to keep changing this up over and over again. And we'll just come up here. So Thursday, etc. So now that we got Monday, Tuesday, Wednesday, Thursday, Friday, we actually don't want to put Friday in there. Sorry, we're going to stop at Thursday and block this off. And now, if any of those conditions are true, what do we want to do? We want to put a 0 because we want to know if it's a weekend. And then conversely, we'll put a 1. So here's what we did. And there we go. That's the other way to do this. So you could do the data index, or you could do something like this, where you coded if or. Okay, so that's how you do that. Either way works fine. I just ask that you copy and paste special value in it, because sometimes this stuff can be unpredictable, especially when you're working with the data and it's something important. Okay, so now we can do the forecast. We're going to use temperature and weekend. So we're not going to use the day, but we're going to use temperature and the weekend. So we'll go up to data, data analysis pack, regression. We're going to go, that's good, but this time we want to change to weekend and temperature. And we'll put it in, we're not going to put it in H, we'll put it in J, because I want to put the forecast error and absolute forecast error in, and hit OK. And there we go. Now look at what happened here, folks. Simple regression brought in a 0.03, but this one brought in a much better 0.62. Our F statistic is still just a tad high, but it's really close to that 5% or lower. Our p-value for temperature is still bad, just like it was over here. In fact, it's still pretty bad, like over here. But our p-value for weekend is very good. So I suspect that weekend is a much better predictor than temperature is. Well, let's find out. So once again, I'm going to cheat, and I'm going to go over here and grab those cells, forecast error, absolute forecast error. Bring that over. Now it's going to say value because there's nothing here for me to calculate, and it's pointing to Monday. So we'll fix that in a minute, but the point is I wanted to quickly bring these over. So what we're going to do now is we're going to use this formula. So we're going to take equals, and I'm going to shrink this just for a minute so that I can see it all on one page. Okay, that did not help me. There we go. We're going to shrink this a little bit so I can see it all on one page. Sorry about that if you can't see this right now, but you saw it in the previous when I did the simple regression. So equals weekend times this plus temperature times this plus intercept. Okay, and we want to do absolute cell reference on anything in column K so that we don't lose that when we drag it down. Okay, and one more. Okay, so now we drag this down, got our forecast. We will data ink that a little bit. And we're going to double click this and move it over here. I don't know if you knew that trick. You can type it in if you want, or you just grab the edges and drag it over. But now we can bump this down. And Bob's our uncle. We are cooking with gas, even though gas stoves are under scrutiny right now. So we can copy this formula here, bring it over, bring this one over, and bring this one over. We do want to be careful that we're collecting everything. And if you watched the previous segment of this video, you know what this is doing right now. Forecast error tries to get to 0 when it does linear regression. So that's why we have set 0 here. Don't be alarmed that you see an E there. Don't be alarmed that this percentage is out of whack. In fact, we're just going to put a 0 there for simplicity. I will bump this to data ink it. But look at here. What is our forecast error? Absolute forecast error, 14. With simple regression, it's 20. And naive, it's 26. So I know this was a long way about to do this, but we have a much healthier model. The forecast error dropped to 14 from the original 26, or down from the 20. And there you have it. That's how you can look and do comparisons between different modeling techniques.